All right, so for y is less than or equal to 5, that is a horizontal line at 5. Okay, and if it's less than or equal to, do you remember dotted or solid lines? Okay, that's a solid line at 5. If it's less than, where would you shade? Underneath it. Okay, this is considered to be a linear system of inequalities because there are two inequalities. What kind of line would be x is greater than 2? Okay, x is greater than negative 2 would be vertical. It would be a dotted line because it is not equal to. In which way would you shade on this one? To the left or the right? Your solution... Yes, so I shaded both. Really, if you do not want to shade on both of them, understand the part that I've shaded twice is your solution area. So if you just want to say what section of this graph is below the y line and to the right of the x one, and just shade in here, that's fine. Okay, do we kind of remember this a little bit? Okay, so we're going to do a couple examples with this. And that really is our day. The rest of the stuff, it's not too bad. Okay? All right, so let's take a look at the second one. You can also do this with two, like y equals mx plus b lines. You graph those just like you normally would. So that first line, negative 2x plus 10. How do I start that one? Up at 10. Should have put graphs onto these. So there is 10. And I would go down 2 over 1 a couple times just so I get enough of where my line should be. And this one, is it a dotted or a solid line? Solid line. Okay, I think it should go through 5. So I'm going to go through my line there. And where should my shading be for that one? I'm not going to draw it right now, but just think. Okay, it's above it. So it's going to be shading above that line up there. I'll just kind of draw my arrow for now instead of double shading. My second line, where should my second line go? Start at negative 2. Has a slope of up 1 over 1. This one is a dotted or solid line. Solid. So there's that line, shade above or below that line. Above that line. So where is my shaded area in this top section in here? Okay, some of you will want to do shade above one, shade above the other, see where the shading kind of crisscrosses. That's totally fine. If you are like a colored pen person, I mean, I can get into that too, so you're more than welcome to shade this way in purple, shade this way in your other color, and see where it comes together. It's up to you how much you feel like you want to do with that, okay? All right. Any questions, problems? Am I running through this too quickly? No. Okay. All right, example 3. 2 of those are super easy. You're going to see a lot of this where your x's and y's are restricted by just a vertical and a horizontal line. And then we're going to have like a 3-part area here. So in order to graph our third one, the bottom 2 here, pretty easy. That's x is 0. That's a vertical line right on the y-axis. Y is greater than 0 is a horizontal line at the x-axis. The third one, what do we have to do to that before we graph it? Solve it for y. So I would subtract your 2x first. And then divide everything by what? 3. Remember, in these, just as other inequalities, if you multiply or divide by a negative number in the process of solving, what do you have to do to your inequality sign?
I'll flip the sign.
Flip the sign backwards, right? Now, this one is not like super nice as far as graphing because of the y-intercept at 20. But you can always count by 2s if you need to.
I'll count by tens.
Count by 10s. Okay. So I've got y is greater than or equal to 0, so that's shading above that. I've got x is greater than or equal to 0, so shading to the right of that. And then I've got a line that starts up at 20 with a slope of negative 2/3. So I'm just going to go up 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And you would do a slope of down 2 over 3. So something like this-ish. And this one is less than, which means shade below. All right, so what's the shaded area for this? The triangle part in here, yeah? So that is your solution area for that. Easy enough so far? Okay, we add one additional thing to this, and that is on 7.2. So if you would flip over to 7.2, my main goal for this, since we're taking the test Tuesday of next week, I don't want to not have a day that we come back and need to answer questions. So 7.2 is really 2 examples. And if we have, if we can spend our Friday like going over that, a little bit of the homework and talking about it in our calculators, I would rather do that. So that's what we're going to do. This sounds super complicated, but what I want you to see is that 90% of this is exactly the same as what we did. Okay? This is called maximizing and minimizing using what's called an objective function. They're always set up the same way. Okay? You have this function, it's usually a profit or cost function, and we have these linear constraints on it, these guys. So we do not graph this. The first thing we do is just graph what they've given us. Okay, we're going to find an area, a solution area, just like we did before. So in this one, the bottom 2 are the easy ones, right? X is greater than or equal to 0, y is greater than or equal to 0. The top 2, what do we have to do to them before we graph them? Solve for y. Okay, so far exactly the same. Y is less than or equal to negative 2x plus 8. Second one, I would have to subtract the 2x and divide by the 3.
Why do you solve for y, not x?
Because in order to graph lines, you need them to be in y equals mx plus b form.
X equals 0.
Right, that's a vertical line. That's different. All right.
Yeah, I'm stupid.
We okay so far? All right. Very basic graphing here. A lot of these, you're going to see this x is greater than 0 and y is greater than 0 because in real life, whatever those represent, you can't have negative things that you're manufacturing or negative prices or negative whatever. So a lot of times you're going to see this x is greater than 0
Somebody $3 to take your item for free.
and y is greater than or equal to 0. A lot of times I won't even graph these. Like if I am drawing this, I'm not graphing those two because I just know that that means stay in the first quadrant. X is greater than 0 is to the right, y is greater than 0 is above. So right now, those two are just restricting me to the first quadrant. The other two is what I'm going to worry about. Y is less than or equal to negative 2x plus 8. So graphing just like normal. The one thing that I will do on these, and you'll see why in just a minute, usually I don't make you count down 2 over 1, down 2 over 1, the whole way to the x-axis. You are going to want to know where these cross the x and the y-axis. I'm going to show you how to do that with your calculator next class. But for right now, a couple of these are pretty straightforward, so I can go down 2 over 1 a couple times here until I land on the x-axis. Okay. You kind of want to know the x and the y points on those. And then the last equation to graph is negative 2/3 x plus 4. So I start at 4, down 2 over 3, lands right there, down 2 over 3 lands right there. All right. Now we find the shaded region, just like we did on the other ones. The easy two, the X and the Y, just push us into the first quadrant. The other two are less than. Okay, so if it's less than both the green and the purple line, what's my shaded area?
Below it.
It's below both of them, right? It's this. Yeah? All right, so that's my shaded area. So far, is this any different than what we just did? No. Here's where it is slightly different, the 10% that is different. That little shaded area has 4 corners to it. Okay? What are my 4 corners in ordered pairs? This one right here, 0, 0. This one right here,
0, 4.
0 up 4. This one over here, 4, 0, and
3, 2.
3, 2. Okay, any issues with those? These are the 4 points that you plug into the equation that we have ignored. Okay? We would like to, keyword, maximize. All you have to do is plug in all 4 of those and see which one gives you the biggest number out. Obviously, not 0, 0. Right?
I think I know it.
We include that as part of it because it's a corner point, but it's not going to be that one. If I plug in 4, 0, I get out a profit of 12. If I plug in 0, 4, I get out a profit of 4. And if I plug in 3, 2, 3 times 3 is 9, plus 2 is a profit of 11. Which one gives me the biggest profit? 4, 0. Done. Okay, that's the 10% that's different. So your answer is that the maximum occurs at 4, 0 with a profit of 12. That is your answer. Okay? The good news is once you've done one of them, they are literally all the same. Okay? I want to do one word problem and then I am done. Okay? One word problem. So far, I'm at 12 minutes and 30 seconds for notes, so I'm okay with that. All right, one word problem on the back. These look really complicated. These tables, make them easy, okay? You want to see the tables because the tables line up for you what is going to be your equations, what are going to be your variables, and what are going to be your the cost or profit function. Anytime you see this, okay, that's your cost function. Remember we said there's that one that we don't graph? It's either cost or profit. This is it. C equals 8x plus 6y. Find that first. I just made the first one the x and the second one the y. What that tells me is that that's my x and that's my y. Okay? So where does all that come into? These are your inequalities. And the nice thing about them, because this is the x and this is the y, is that you simply roll through all of that as one inequality. That's going to be like your C value on the right. So that A right there, that means my first inequality is 3x plus 2y. Okay, it says we have to have at least 160 units. So that's greater than or equal to 160. What's my second inequality going to be? 5x plus 2y is greater than or equal to 200. Third one?
1x, 2y greater than or equal to 80.
Okay. Those tables make it really easy because you just have to run across them and make your inequalities with that.
So to be a big
Okay. Now, what is not included in the word problems but should kind of make sense? If you're buying bags of each of these brands, can you have less than 0 bags of each? No. So what I'm going to include in this is that x is greater than 0 and y is greater than 0. Okay? Those are not going to be stated, but they're pretty much always understood in these. So all I have to do in this now is graph these and find my intersection points. Now, this is a great one for your calculator because if you try to go through and solve this, your y-intercepts are going to be like super high. I'm not looking for you to try to find these intersection points on your own. Realistically, I don't need you to go figure out where 3x plus 2y is greater than or equal to 160 intersects with the next one. So this is where you're going to want to use your calculator. You do not have to graph inequalities. Graph them as lines, okay? I'm just going to pull up one calculator and do this for the sake of like finishing this up and assuming that y'all can graph on your own calculators, yeah? All right, so take a minute on your own papers. Solve all three of those for y for me while I pull up my calculator, okay? Solve all four of them for y. If you want to do it on your calculator and follow along, feel free. I'm going to pull this up, and we're going to graph. There we go. All right. Who solved the first one for me?
Y equals negative 3 over 2x plus 8.
Okay, y equals negative 3 over 2x plus 80. All right. If they're all greater than or equal to, it's all out there, yeah? Okay, so when it's all out there, you still have corners. Now, it's infinite, okay? But we would like to minimize the cost. So do we really care about the big numbers as it goes out? No, we care about the corners on the inside of this, okay? So I'm going to, before we do our points, I do still have to see one more thing, and it's where those lines go out to the right. I'm not quite there yet. So what I'm going to do real quick is change my X max to see where those cross, because that's going to be one of my corner points. Because remember, we're greater than the x-axis, and we are greater than the y-axis as well. So I'm going to go ahead and make my x max a little bit bigger, maybe 100, and just see. Okay, now we can really see. So here's what we're worried about. Our shaded area is out here. Where are my corner points that I'm worried about here? Right there. Right there where they intersect, where the blue and the black intersect, and one more, the x-intercept over here, yeah? Okay, so I'm worried about those 4 points, so that's what I'm going to solve for real quick here. All right, so we're erasing this because that's my drawing there. I am going to graph trace to get back to this y-intercept. You can do a lot of graph tracing on these because your graph trace, especially on the Inspire, will pick up some nice points. Like if you see it's on the blue line, but if I keep going, it typically pops up an intersection point. It doesn't always. Sometimes it will, sometimes it won't. I'm going to keep going. Whoa. I need this line. Hang on. I need to graph trace on my red line. You could try trace all. That's an interesting one. Whoop. Hello, Mr. Cunningham. How are you?
Oh, can I make an announcement here?
Sure.
Wait, are you guys in the middle of something?
Go for it. They're not in the middle of anything.
You guys remember my old calculator with the C burned in the front, right? Yeah. You guys remember that guy? It's missing. It's gone missing.
Uh-oh.
So I think I lent it to somebody. They borrowed it.
And I'll kill him.
I appreciate you, Dave. I think that they probably just forgot to return it to me.
You're so
So
sweet.
it doesn't matter. I just want it back. So just be on the lookout for it. Let me know if you see it. It's an 84.
But it's a fat old 84.
It's one of the fat 84s. Yeah, old school. I had it since
Well, you
seventh
know a
grade,
lot
so,
about
you know,
it, Zach.
and it holds a very special place.
Yeah, it's in my house. Oh, we'll find them.
Appreciate you guys.
All right, I'm going to finish this up real quick, guys. All right, so you're going to use your different analyze graph stuff here. All right, focus. Okay, there's that intersection point. I'm going to pick up the intersection point. So the moral of the story here is we have 4 points to check. This one's 0, up 100. We want to this time minimize. So now we go back to that equation that we had. We had the cost function is 8x plus 6y. If I plug in 0, 100, my cost is 600. And so on. Minimize. Okay? We are doing check my PCA for which questions you're doing for homework. We're going to do a few from each, but not all. So don't. Okay?
See how good I was doing back there?
Yeah, it's just great. Not chatting at all.
No, listen, I did not take my phone at once, and I was locked in on answering this.
Were you? I don't know. We'll see.
Like,
I knew you were there.
Back there? Just can you give me one more chance next time?
Maybe.
I won't talk.
Questions?
It was
Yes.
Bill talking the whole time. You heard it. Right?
Josh, are you going to lunch with us?
Wait, I can't hear you again. Why can't I hear you? What's happening? The quiz did what now?
Well, you said I did a good job.
Josh, come here. Josh, come
It
here.
closed again? Okay. I keep changing my times. I'm just rolling with it today. Struggle bus. All right. Let me change my times. I will get it.
Excuse me real fast. Oh no, we got some virtual learners.
All right. I'm saving this
Yeah.
What's on my glasses?
and try to submit again.
You did?
Is it?
Yeah. So this one is the right answer, right? How would I write that again?
You would just say the maximum is 40 bags of fast grow, 20 grow, okay, whichever one it is. This one, yeah. So it would be 80 of that with a cost of this. Oh, you want to minimize on this one. So since we want to minimize, so we want the smallest. So then you would say the minimum cost is this much with this many bags of the first and the second. Yep. Hello, friends.
I'm not crying.
No, you're not. How
Last
was it?
time I was.
Gracie, is it up there for you now? I got it. Okay. Thank you.
Did she put?
I don't know.
Did you put it in the?
I did.
So it was during
Yep.
and then did you ever see my test?
I did. I got it. It's graded. It's in. No, but it was close enough that we're okay. So just quits. Then we'll be fine. We're gonna finish the quarter. We're gonna go. It's gonna be fine.
Not awful.
Not awful. Test was not
I
awful.
probably failed. Because normally when I think I do bad.
I failed at this.
Normally when I think I do bad, I
Woo!
do well. And then when I think I do well, I do awful.
Okay.
But
I don't really. I'm kind of following.